Hey, how's everyone doing? It's a good day today. Woo! We got Hackerman in the background. Why is Hackerman going? Hackerman's just going to go 10 times. I got to see what's going with Hackerman. On assignment 44474, I can't figure out how to specify month of the year for my data. We can see trends of seasons for video games. Good question. It's Wacky Wednesdays. We'll hit that button here in a second. But Gia, I think the data set doesn't have months. Dun, dun, dun. There are no months for it, Gia, I think. There's no months for it, so we can't do that. Wacky Wednesdays everywhere. No months. Put on a little music here in the background. There's no months. Oh, no. So we can't take the months out of it. Good question there. We could look at some assignment 4. What do people want to look at? So good to see everybody. We'll make sure Mubot is awake. We're gonna, okay, good. I think I didn't waste my time trying to figure it out. Yep. If the data doesn't have it, we can't use it. Man, that'd be cool though. That's what I really wanted. If it had the month of year it was released, we could figure out like hot months and cold months, historic trends. It could become a time series analysis. So that data set, if it had months, would be so great for 475, excuse me, because then the time series analysis on it would be pretty insane. Like amount of video games released during that month, units sold from a video game released that month, because it's not like unit sales that month. It would be like this game was released that month and how many sales do games do for like monthly sales. 475 for today's assignment. We have to run the decomp correct. It feels easier. Too good to be true. It is. I'd say it's easier. Yesterday you told me to use genre and make table, but I nulled out because before scaling it. So how can I do that? Reload the data. Reload the data. Save your vectors to the side. Reload the data frame as a copy. Add the copy back in. Does that make sense, KP? Reload the data as another data set. Take the vector, append the vector to the data frame. KP, if that doesn't make sense, I can show you how to do it. But reload the data as a new data frame, like store it as like video game 2, VG2. Then take VG2 $genre and append that to original like video games $genre, and then append VG2. Kevin, good to see you here. If that doesn't make sense, KP, let me know. But yeah, let's show you that right here. And if you're in 474, Coding Night's coming along right here. Let me show you a little peek of Coding Night, and then we'll take a look at some of what KP's asking right there. Let's go check it out. So I have the answer key for Coding Night now. Dun, dun, dun. The full answer key for Coding Night. Everything answered. Brian did all the work. Think everything is good. And then I'm writing this right here to check all your answers for Coding Night. I should have finished up here soon, but this right here is going through. And if you look at how I'm doing it, I'm using for loops with if else's. So it goes through your last chunk. If it evaluated was true, I have to set that myself. So I go and I run your last chunk. If it evaluates, you get 5 points. And it says, I love grammar. Your final chunk evaluated for 5 points. Your final chunk did not evaluate. So that'll say that right there. So you can check it out. And then it says your score. Oh, that's it, Dan. Question blank was correct. And you see I'm using a for loop with 20 questions. And just so you can see, I create a vector of correct answers here at the end. So there's my list of correct answers, and then I go through and I check your answer to see if it's identical. But here's what I really want to make sure I do is I want to look at your answers to make sure maybe you named the column, maybe you did something a little bit different. Let me mark this part of the video so people can use it for later. So maybe you marked the column, maybe you did something a little bit different than I did, where it's basically right. So this is BS474 Coding Night grading update. And I want to make sure I take a look at the answers you got wrong. So these are the ones you did not get correct. And I had to check these answers right here. Does that make sense? A lot of code going on, but I want to basically make sure I look through all your answers and check, okay, you missed this one, you answered this, but you answered this. I probably should just append these right here. It's going to be the best way to look at it. Run them both together so I can see what the student answered and I can see what you answered. I mean, I can see what you answered and I can see what the key says. Mubot telling all his jokes right there. But I want to see what you got wrong, and I want to double check it before I'm like, okay, this is what you got wrong. So I'll probably take your vector, put it up here, and run all your answers. Riley, good to see you. But that is my goal, is to get the coding done and efficiently, and then you will get something printout saying you got this wrong, you got this, or you got this right, and your last chunk evaluated for 5 points. And then at the end here, it says your score blank. You scored blank points on the exam. But yeah. That's what's going to happen for coding night. So check out the grades will be coming soon here, and Brian will get caught up on grading. Shouts to my 201 grader helping out. But let's talk a little bit about KP's question right there. And is the link to join in Canvas? I don't know yet. Maybe. I don't think so yet. Teams invite. I can post and check after office hours. Busy day, busy day. There we go. Busy day. I was doing some texting before office hours, but now I had to send one last message right there. So let's check out KP's question. Let's put it in the notes right here. And this is adding back things you've deleted. BA is 474, adding back columns after nulling out. Okay, KP, this question goes out to you here. So what did I call it? I called it video games, did I? So let's go VG right here for video games, read.csv. You're welcome, KP. Thank you so much. This is one of those days where I'm going pretty quick. Woo! Brian's got all his coffee in him. Got 8 hours of sleep. Was working a lot of work yesterday, preparing a big presentation today. And then I'm going to send out a reminder to 201 about the Kahoot tonight. So we got presentation in Kahoots. Cool. Oy. And now strings as factors equals true. Okay, so there we go. Probably going to end just a tiny bit early today. Yes, Jessica, awesome. Going to end office hours a tiny bit early because I've got a bunch of things. So we'll end like at what time? I have to do the Knoxville conversion, 11:40. Also for scaling, we figured that out by running the summary right. Well, when you scale, you turn things into what, Gia? And 201, listen up to this. When you turn, I'm not a big fan of the max mins method of scaling. You can do that. I prefer to just turn things into what's. Like max min's fine. That puts it on a 0 to 100 scale. That's a fine method for scaling, but I'm not, I do z-scores. And you can just use the scale function for that and just overwrite the column. The activity does that. And so I'm a bigger fan of doing it by that methodology. It's just my consistent way of doing it. I think it's quicker, it's easier. But one problem you run into is a lot of people don't know about z-scores. They're like, what's a z-score? So you then want to use the original data when you talk about things. You want to go take your clusters and then talk about the original data. And so if you were to null something out right here, and great job asking all these questions, everybody. If you were to go here and go to video games and go to genre, and you were to remove it, it's gone. So what I would suggest doing, KP, is I would take this, I'd put it down here as video games 2, and then I would go to video games 2, which is a copy, or you could call it VG copy for video game copy. Anything's fine, but usually we like to call copies of things copies. And then I would take in it the genre, and then I'd go here and do this. Does that make sense, KP, on how to get it back in? Is you could load a copy of it, and from that copy, take the vector you nulled out, and then just append that vector on. Now, it's going to be at the end of the data frame now. You could rearrange and do things, but this right here should do it. Yep. So load a copy of it, grab from the copy the thing you deleted, because you deleted it here from the original data frame, grab from the copy the vector you want, and then append the vector on here. Let's see, I'm going to do one thing real quick. Let's over to the main screen. Let's get some more questions. Who's wondering about anything right now? Who has questions? Drop those questions in the chat because it's open question time. Open question time. I don't see the invite. Don't see the invite. Don't see. Forward the invite. Okay, need to forward someone an invite. Whoa. Message couldn't send? What? Wake up to a message couldn't send. Oh my gosh. What is going on? When is the review for exam 2? We're doing a Kahoot tonight. I'll be sending out that announcement. I'm gonna resend this. So after scaling is when we do the k-means for our data. So did you transform your data to? Did you also transform your data? I highly suggest that. Did you transform your data? Let me see. I need to do one last thing right here. Did you transform your data? Because if you don't transform the data, the variables with the biggest scale are going to take over. So watch out if you don't transform. If you don't transform. Let's see. Lab 4, question 2A and 2B. That sounds great right there. Will the review be recorded? It'll definitely be recorded. Make sure to transform. Does the 474 assignment 4 grade still on processing? Can you clarify, Yakui? We are finishing up grading. That is correct. That is correct. And I need to send one link right here. Sending a link. Let's see. I think this will work. Copy link address. Probably need to call someone after this. Yes. So busy. One of those semesters. Let's do. Stevie wants to question lab 4, question 2A and 2B. Stevie, let's go grab that right here. Have you graded the mortgage calculus homework? Awesome. I have not. We're gonna have that graded here soon. Thank you for asking about that. That has not been graded yet. Has not been graded. Let's get the lab going here. Some 474 today. BS 474. And getting it loaded up. Mortgage calculator has not been graded. Not graded yet. We're getting coding net graded and the mortgage calculator graded. But let's go look at the lab here. Lab 4 clustering. Downloading the RMD. Getting the RMD ready. And here we go. Thank you so much, KP, for the clarification. 100 points right there. I appreciate that. And let's jump into the lab. Here we go. 475, I got confused with you'll be decomposing 3 different time series and must use 3 different decomp models. Yep. So with the 3 different decomps, Shreya, make sure to do like an additive, multiplicative, the X11, the classical decomp. Lots of choices. Just don't do the same decomp through all of them. So don't do like the same additive decomp. Yes, good work, Shreya, right there. 100 points. Awesome. Let's take a look at 2A and 2B. 2A and 2B, dendrograms. Okay. So with dendrograms are actually what we call agglomerative clustering. What does agglomerative mean? In 474, who knows what agglomerative means? We talked a lot about divisive, but what is agglomerative? What does it mean to agglomerate things? So we should still have the notes up. What does it mean to agglomerate? What does agglomerative mean? You can see what agglomerative looks like right here. Things all clumped together. So we start down here. Great job of Noah and Noah right there. They start out by themselves. So everything starts out by themselves, individuals, and then they start clumping together into these clumps up here. Now, what's really interesting is there's actually a point at which right there are 2 clusters. It's very hard to see. And there's actually a point at which there's 3 clusters. So when you do hierarchical clustering, you're really looking for what I call the legs of it. So I draw this little monster. I'm obsessed with the monster mans and stats. So when you draw this right here, you want to see if there's good separation. You don't always get good separation. Sometimes it's a little bit confusing about, are there 4 legs? Are there 2 legs? This is a decision you have to make when doing it. You can't always know the right answer, because what's the right answer to clustering? There's no right answer. I mean, it's just your idea about how it looks as clusters. So data can look a little bit different and sometimes come out with different results, and sometimes it looks pretty crazy. What's the right answer to how many clusters are here? Well, interestingly enough, what do you notice about the very end of this? And then we're going to go into the actually working this. What do you notice about the very end of this hierarchical clustering? What do you notice about the very, very end of this hierarchical clustering? Look at when everything starts coming together, what happens at the very end? Can you explain to me like what's going on right here? Remember, the points are coming together. So what's going on? I think Enola sees it, right? Enola, I think you're seeing it. Well, at the very end, it all becomes 1, right? But what is the last merge? The last merge is all of this. The last merge is everything with 1 point. So like all the data clumps together into one thing. And then there's this one extreme Stats 1 should know this word. There's this one extreme person who's a very big outlier. Riley, great job right there. That's it. There's a big outlier, someone who's very different from everyone else. So we have, great job, Jessica. You see, we got outliers everywhere. So that person right there is very unusual in all of these characteristics. So the idea of clustering is you bring like-minded things together. So I love the Stats 1's hearing a little bit about this right now, because we're just trying to figure out where the data is clustered into groups. Like, what would make the most sense to put it into 3 clusters, 4 clusters, 5 clusters? We can show visually. We did a 3D plot of the clusters yesterday. I thought it was pretty cool. So we were making like a 3D plot and looking at where the clusters were at and looking at it over different characteristics. Now, this is just over, you say, well, that's not really good clusterings. They're all kind of on top of each other. We're doing like 6 or 7 different X variables. So sometimes they look separated, but if you look at it on a certain dimension of like height and weight or something, well, then there might be overlap. I mean, we did height, weight, GPA, distance from school. So when you start doing clustering, you try to look at it visually on a few of your X's, but you can always look at it more on your X's or different combinations of X's. So the goal is like-minded things are put together. We'll just look at the theory of clustering again really quickly. It's just important to understand, what are we doing? There is no right answer to how to cluster things, because how would we cluster these items here? Would we cluster it by shape? That's fine. Would we cluster it by edible, not edible, or color? No, that's color. But then if you go this way, it's edible, not edible. So you could do clusters like that and say edible, not edible, or you could do color, or you could do shape. Which way is the right way, Shreya? Which way is the right way? That's the answer. I love stats because of that. That's what drives people crazy. There's no answer. All of them, none of them. So whichever one does the best for the business. So you're just trying to figure out like segments of your population and how to talk about them and make ideas, which is what we do here and what you need to do in your report. So as you're doing your report right here, you want to figure out ways to talk about them and group them together. There's no real right answer. It's just like, this works, this doesn't work. There's better answers, there's worse answers, but there's no right answer to any of this. There's just, hey, it's a good answer. Last question, 100 points. It's called what learning? And then we'll start doing the work here. It's called what learning, because there is no like objective answer. There's no going to this answer right here. It's called what learning. There is no like direct, this is the answer. It's called what learning. What do we call it? Unsupervised. Kirsten, 100 points right there. Great job. It's called unsupervised learning. We're not going towards a direct answer. We're just like, if it works, it works. And there's the divisive right there. Divisive is what we did with our elbow plot and what we did with the k-means. And now we are starting today on linkage and all that good stuff. Let's go look at the questions and start working on 2A on the dendrogram. Okay. Do we have to have the data load in up? We need the data processed. I need to redo it. So this is a quick way of doing it right here. Done this a few times. We did this yesterday. So right here, we've got the data processed. Oh, I need to mention, load in this, data processed, and everything actually gets the log 10 transformation. So we can actually go 2, 3, 4, 5, 6. 2, 3, 4, 6. And we're good to go. And double check this. There we go. Dun, dun, dun. Oh, we didn't remove the... Oh, we can remove that now. Let's remove those columns, region and channel. Oh, is that going to cause an issue? Probably not. Data.processed. And that deletes those. Delicacy is not right. Milk is right. Groceries right. Frozen's right. Detergents and delicacies are not correct. Dun, dun, dun. Did we not change those? That's changed. Why didn't they change? Who knows for 100 points? Why did the last two not change? Why did the last two not change? I know the answer. The answer dealt with this. Why did the last two of these not match the sanity check? So the answer has to deal with this. Does anyone know? Slowing it down, letting you see, because I see it now why the last two don't match. The last two don't match because I didn't remove the first two columns. So when I did the log 10 transformation, I did it to the first 6 columns, but the first 6 columns weren't my data. The columns 3 through 8 were my data instead of 1 through 6. So what I need to do is I need to remove the first 2 columns, and then columns 1 through 6 are my data. So going back right here and rerunning the chunks, we'll get the answers now. We don't got to worry about the plot, but now we could actually look at the check right here, and we can see we do... Wait, we got to scale it. Oh, it got mad, I think, about making the plot. So let's run everything here. Let's remove the plots of the histograms because we don't need those. And then let's run the data. And now we see... Do we not know those out? Oh my gosh. Put your code in order. This is why we check things. And why is... Do you see it? Do you see it? Oh, the smallest of errors. The smallest of errors. There we go. The smallest of errors create the biggest of problems. Choose the wrong data set. Don't null out the right things. So it's like nothing was changing. I know, right, Shreya? Little tiny, you just have to look and say, okay, what's going on? What's not matching up? What's not working? So I was using data processed up here. We want to go to the whole data set, load it, remove those columns. I had that out of order to begin with. And this is what you want to do. If you're writing code, you want to make sure it goes in order. So that's a big thing. We all make those kinds of errors all the time. Now that we've got the data processed, we have met the sanity check, so we're good to go. Let's go grab the data processed and go down here to question 2A with our processed data. And this is what you want to do to get your data ready when you're working with the video games data. Q points, nice Q points. So run the H clusters right here, and we're running it on the processed data, and it should make the dendrogram. So let's go grab the code for H cluster, because H cluster, here we go, just takes a distance matrix, and we don't need to worry about adding a line. And here it is right here, takes a distance matrix of the data we're using. Why are we using the processed data? Worry about that in a moment. Why are we using the processed data? Who knows? Change some arguments here a second. Woo! Just taking a look at it. What do we got? Stray level achieved. I'll worry about the methodology at once in a second right here. I'm just running it with complete for the moment to take a look at what we got. I'd say there looks to be, and I wouldn't cut it that height right now, I would say, how many clusters do you think there are right here? How many clusters are there in this data looking at this graphic? I'm going to remove the 80 line. How many clusters do you think there are in this data? How many clusters? So I'm going to help with your eyes here and see how to do this. Let me get my, I think I've got some graphic. Okay. How many clusters are there? Who knows? How many clusters? Can you tell? How would you know? What do we look for when we look at a dendrogram? So I think Michelle got it right there. Michelle, 100 points. That is correct, I believe. 1, 2, 3, 4. I think of this as like a chandelier. And if you cut this chandelier across there, like you take a big samurai sword and you go, wah! And you cut across, how do we know where to cut? How do we know where to cut? What do we look for with this monster man? What do we look for? We look for the monster man's what's. So what do we look for with the monster man? We look for its what's here. Because those are like its toes. We look for its legs. Does that make sense? So we're looking for the legs of the monster man. So sometimes it doesn't have as clear of legs. So you're kind of trying to find this separation area. Like maybe some people might say 2. Like I think you could say it has 2 clusters. I think you could say it has 4. Those are possible answers right here. Can I put that in? Yeah, I'm grading it. So like one time my grader was like, that's not like a student made a joke or something. I was like, I said that in class. They're like, you shouldn't say that in class. And I was like, I don't say anything bad. This one is this one I don't know. Probably 3, that outlier, and then you got 2 main clusters, that and that. Does it make sense if I talk about like a chandelier falling, that if you were to cut across this, then you'd have this fall down, that fall down. You see how it's like clusters falling down? Does that make sense to everybody? Like these are strings hanging, and it's just a big chandelier, big pretty chandelier on the Titanic. And then all of a sudden, someone comes through with a samurai sword in the Titanic, true story, and cuts it down, and you just see this fall, that fall right there, and you have 4 clusters of the chandelier on the ground. So that's what you're thinking about here is where are the clusters and where's the separation? Where would they slice to get a clean slice through it? And someone could say there's 2, but the reason I'm a little against saying 2 clusters, if you go with 2 clusters, your one of your clusters is just what? I'm kind of against this. I'd be against this idea. Why would I be against the idea of 2 clusters here? Because then you have all the data but what? 2 outliers this time. All the data but 2 outliers. All the data but. It looks like 2 outliers. Those are the row numbers right there. It looks like row blurry number something, row 156 and 76 or something. So there's 2 rows right there, and they're the 2 outliers. We could go get the cluster IDs for these and find out, but they're just 2 outliers over there. So I don't know about making a cluster of just 2 individuals and then everyone else. That doesn't seem that powerful in the analysis. Let's look at how they want us to do the cluster, because there's just infinite ways to do this. They are suggesting right here, let's see. Print the corresponding row. Wait, run the H cluster complete linkage. So we did that on the data process, the transform, blah, 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 blah. You'll see the intervals joining the clusters very late in the merging process. We saw that over here. Print out the corresponding row in the whole or your logged for one of them and identify what makes this client so unusual. So we do need to look at these individuals right here and figure out why they are so unusual. And so let's go to the H cluster and let's go here to the merge. That's so cool. There's so much information you can get from this. We want to cut it. We want to cut this tree. So we need to use the cut argument. And there it is, right? Cut tree. So let's cut it. And so K is the amount of clusters. We're going to cut it to K clusters. You can also cut at height. Not a big fan of cutting at height because you actually have to then look at the tree, right? Or look at the dendrogram and find a height to cut at. It's much easier to go here and say cut so that I have, let's say, how many clusters did we say? Remind me again of how many clusters. It'd be really easy if we did it this way. We could find them super quick if we just cut this way. Now, I don't suggest this is a clustering scheme, But if we just want to go investigate those individuals, a little hard to see their row numbers right there. But if we want to cut the quickest way to go find those individuals, let's cut with this many clusters. The quickest way to cut to go find those individuals is going to be to cut how many clusters off this. I want the quickest way to go find those people. How many clusters do you think I'm going to cut? The quickest way. How many would you cut? I just want the quickest way. That's my only objective right now, is to go find those people. So let's cut how many clusters? Any ideas? I'll give another 10 seconds here. The only objective is just to go find those people. 2, Kirsten, yep. Yep, so now we got, and Kirsten, great work right there. We've just got a cluster of like the main group of people and a cluster of our outliers. So we can go and analyze it this way by figuring out what's going on with those two groups. So there we go, flyer. We don't want flyer. We want, we'll say whole food, whole clusters. No, because we're doing data process. There we go. Cluster, so clusters 2. And these are the IDs right here. Okay. So what this did is it put the IDs of the cluster at the end of this. So actually pretty quickly we can go to cluster IDs, and guess what we have? There's our 2 people. Once again, that 2 represents those 2 individuals right here who are on cluster 2. Does that make sense, Kirsten? What I've done is I've created cluster IDs, cluster 2, which is these 2. It's not because there's 2 people. It's just it called this cluster 1, which is everybody but these 2 people, because I cut so that there's 2 clusters. So this is a label. It's not an amount. I think people know that. It's just happenstance that it is 2 people in cluster 2. Great job, Kirsten, right there. So we basically have these individuals, which I think we already see why they're weird. You can kind of do this pretty quickly right here and see if they're extreme. They're extreme on the delicacy. Ooh, there we go. They have very low detergents. They're not a big fan of those detergents. I don't see them popping up on... Oh, whoop, there they are. They do not buy groceries. They are very against groceries. All of these values right here are what's for them. Now remember, this is the scaled and transformed data. Every single value, they're really against groceries, and this person doesn't like milk. So they don't buy groceries, they don't buy milk. All these values are what's. These 2 people really don't buy groceries, they don't buy milk from the grocery store. They don't buy detergents and paper. What do they buy? Maybe frozen? Huh. Let's go look at it a little more algorithmically. What are those values that we are seeing? What are those values? Dot tilde. What are those values? Does anyone know what those values are? What are those values and what do they represent? And how do I know like they're low on this or high on this? Those values I'm looking at, which I'm going to be looking at here again in a second, are the what's for these groups. The values right here are the what's for these groups. Oh, man. They're the z-scores, Rod. Great work. So we can really... Graphic error. There we go. Great job, Rod. So here is group 2 right here. And group 1 is kind of average. Now remember, group 2 is just 2 individuals. But group 2 looks to be our lost customers. They just don't shop with us, it looks like. They're super below average on everything, but really below average on groceries and really below average on milk. We saw that grocery thing, so they just like don't purchase. Maybe they're people who like signed up for our card and then just never walked into the store again. Or they do like some sort of online shopping where they're only buying, of anything, they're buying frozen. They're not big shoppers, but maybe they just stock up on frozen and some fresh. Maybe they're just like a person who just like has a, I don't know. They're very odd compared to everyone else who is, it's like, here's your average people. Here's your people who just don't shop with you. Not super informative. And if we go over here, we could actually get the individuals. Let's write a quick code to just get those individuals. You can view the data set to find them. Let's go to which and data processed. Cluster 2 equals 2. There's the rows of the individuals. Oops, really? There's the rows of the individuals. And let's go to data processed. And inside of data processed, let's just grab the rows. And this is the same sort of thing we saw earlier, but there's the rows of the two individuals. They eat only Hungry Man frozen meals. I like that right there, Michelle. That might be what they do. They just walk in, get some Hungry Man frozen meals, and they get a little fresh veg to put on top of it. They're like throwing a little lettuce on top of it. Like they just buy vegetables. You see right here, there's these people. This person is actually a little bit higher than average in the delicacy. I don't even know what that is. Maybe it's like nice cakes that we make. This person, they're buying fresh and delicacy. This person just doesn't really buy anything. They're below average and everything with the negative Z scores. So yeah, pretty interesting individuals, but these are our two people who just don't quite act like everyone else, which is fine. So now we got the Ward's distance methods. The Ward's distance is the within cluster sums of squares. That's deli products. Michelle, 100 points. Didn't know that. Delicacy, deli products, deli. Oh, so they're buying some sliced ham and stuff. Oh man, they're not eating so bad. Maybe this is an error because maybe grocery. Well, no, this is individual categories, which add up to the total. I don't know. They just love going to the deli. Maybe they work like across the street and they just walk in and they buy deli sandwiches. Like that's all they buy on their Kroger card. Which, think about that, if you go to Kroger, it'd be weird because maybe we'd expect them to come back. Like if someone goes to the deli a whole bunch at our Kroger, then we'd expect them to come and buy their groceries. But they maybe work near this Kroger, but they prefer to like go to another grocery store for whatever reason. And so we don't get their regular business. We only get their I'm buying deli sandwiches business. So maybe we could pull them in somehow and be like, hey, you love the deli sandwiches, but hey, if you buy this, we'll, I don't know. No cook day, eat at deli. Yep. They just buy from the deli and they buy a little like lettuce to put on there or something. They don't buy groceries from us, which is a lot of our sales for most people is groceries. So pretty interesting individuals. We got the Ward's method. And so we're just going to grab our hierarchical clustering again and change the method to Ward's distance 2. There's actually a lot more methods. Like there's a lot of methods. Like people come up with a lot of ways to do hierarchical clustering. Treating the distance of clusters as the increase of the sums of the squares of the total distance. Uses within cluster sums of squares from their cluster centers once they merge. The scheme is not as sensitive to outliers. Plot the dendrogram at a horizontal line at height 11, which we can go right here. So let's grab the AB line. The AB line is going to be added to this right here and add the AB line. If we got here, how many clusters would result? Great question. Everything should work. That's what we say when things are going to not work, right? Everything should work. And it does. We're going to add a color to this. Col equals hashtag, you know what we're doing, FF8200. There we go. Okay, I need your answer right here. How many clusters result from this? Oof. Oh, that's a hard one to look at. Oh, man. I don't want to tell me. Okay, I got it. Boom, Joseph got it quick, too. Joseph, quick. And you're on a delay. That was great, Joseph. Joseph, that's worth another 100 points. It is 8. I'll show you how Joseph got it here once I press the points button again and leave the screen. Joseph said 8 because 1, 2, 3, 4, 5, 6, 7, 8. That's 8 right there. You have to look at how many times it intersects. I probably wouldn't cut there. You could if you want. This is a lot cleaner. Once again, not as sensitive to outliers. How many clusters would you go with right here? How many clusters would you go with? I think there's a few. You could go with 4. 4 would be cutting. 4 is fine. 4 is like 4 is as big as I would go. You could go with 3. 3 is a good answer too. It could be 4 if you cut right here. It could be 3 if you cut right here. It could be 2 if you cut right here. I might not go with 7. You could. I can't say it's a wrong answer. 100 points for 7. Maybe that's the best answer because you want to make different groups to market to with different strategies. So maybe you found 7 really good clusters, Michelle. That could be the answer, or it could be a good answer. I don't know. None of these are right answers. None of them are wrong answers. We'd have to see how they work. We'd have to make the clustering scheme and look at it. So if you wanted to do that and cut and make 7 clusters, we're going to grab the cut code right here. Just think about what you're doing. You're just cutting the tree. So we go right here. We take our hierarchical method that we've stored using Ward's distance. We did overwrite our last method of doing it. And we're going to go right here and cut with 7. Now I'm going to call this cluster 7 wards distance. And now we get our cluster 7's wards distance. I'll drop this in the chat too, because a lot of what we do is very similar. Because now I actually want to look at the clusters by going back and running the aggregate function. So the aggregate function, let me just kind of make sure people know what it's doing. It reads the following way. Aggregate reads all the y variables of interest, which are all the things we want to understand, like what are their groceries, what are their this, what is their that, and I highly suggest using that on your assignment. We used it on Monday and Tuesday, I think, too. So every single y variable by the clusters. Now, what's sad is we're going to actually see cluster 2. What column is that? The 7th column. So I'm going to go here and remove the 7th column. The reason I'm doing this is this should remove out. I'll show you it both ways. Look at those decimals. Let's go to a round. Okay, round. Oh, is it going to get mad because that's categorical? Oh, it didn't. Yay. If you don't remove this out, you just get the cluster 2, and you can kind of see where your cluster 2s were at. That's not the end of the world. You could also just remove this also because it reports a table, I believe, too, so you could remove that last thing off. I'm just removing it to begin with so we don't see it. But all in all, so the 7 clustering scheme right here, what do we see? Does anything jump out to you here? Who's our below average customers? So who's our below average customers? 1 through 7. Who's our below average customers? There's no real pop to any of this really, though. Who's our below average customers? Which cluster would be our below average customers? 7, yep, Joseph. So they're almost average on frozen, but they're below average on everything. Let's try something different here. And I'm going to call it 7 just because I don't want to create more columns. I'm going to cut with 3. And here's 3 clusters. Let's see. Day does not turn out so pretty today. Here's our above average customers. Here's our customers who don't like fresh or frozen food. But these are our champions right now. They're the ones buying everything from us. Maybe let's try 4 clusters. We're just investigating right now, and I'm just not changing the names of the values, so I can just run it and not worry about extra output. Once again, this is the low cluster. Here's our above average cluster. Why am I saying this is above average? I'll pause right there and make sure everyone knows. And great job, Michelle, also following along. Why am I saying that is above average? Like, what catches my eye? I'm like, okay, that's the above average cluster. This is the below average cluster. This is the cluster that is close to average, but is below average on groceries. This is the cluster that doesn't like fresh and frozen. They really like groceries, milk, and detergents. The signs, yep. And what we really would like, what we really want is we want some z-scores, which don't do this. This is a little wacky. We really want some z-scores like this. Now, if you're in Stats 201, why do we really... Maybe this is the right idea. This is a lot of clusters. Ooh, little scary right here with this many clusters, though. Because now a lot of the clusters are about the same. Like, what makes every cluster unique? Cluster 7 is very unique. And why is cluster 7 unique? And let's find out how many people are in cluster 7. Why is cluster 7 unique? Talk to me about cluster 7 for a moment. Why is cluster 7 unique? Talk to me about cluster 7. Why is cluster 7 unique? Why is cluster 7 unique? They really what? Talk to me about cluster 7. They really hate fresh food. You say, here's some broccoli or something. They're like, oh my God, this is gross. I'm never buying fresh. They don't buy fresh food. So in Stat 201, we learned z-scores outside of 3 and positive and negative 3 are outliers. So Kevin from the office, there you go. Kevin from the office right there in cluster 7. How many people are in cluster 7? There's 6 individuals. So now I just made a table of how many observations are in each cluster, how many individuals. So that's 6 people right there with some rather extreme tastes. And you could also go and make a subset of them if you wanted. Subset, data processed, and then cluster, what is it called? Cluster sound. And so we could take a look. And there they are right there. There's their fresh scores. You look, they really don't like fresh food. These are all, that's their main unifying characteristic, especially this person right here really, really doesn't like fresh food. Then you can see their grocery is a little bit above average, and we see that right here. Well, I shouldn't have a negative. What? Oh, that's grocery. I was looking at milk. A lot of output. Is this, who feels like this is making a little more sense? Like that's 2A and 2B. We've done most of the activity now. Are people feeling like the idea of clustering is making more sense and we're just bringing people together and there is no right answer? But drop more questions because this is 2A and 2B of the activity, talking through it, understanding what we have going on with the data and making sense of it. So what are people's thoughts right now? Let's head back to the main screen. We can do more of the activity. Your call. 201. We can do some 201 if you want. Canvas content. My Pearson. What are people's thoughts? We'll play our favorite song. What are people's thoughts right now? What are you working on? Let me see. Okay. Might need to call them to figure everything out. Woo, busy day. So when we are doing the assignment, do we turn the categorical variable into quantitative? Which one? Which one, Joseph? Can you talk us through population parameters and sampling from... Yeah, you asked about that yesterday, right? Let's do that, and then Joseph, expand upon that. Okay. Like assign a code for all the different genres and publishers. Kind of. What you'd want to do is if they share the publisher, you'd want a 1. So Joseph, the best way to handle that, this is more of an advanced thing. I've suggested to people they null it out to begin with, like just not deal with it. Just kind of exclude the categorical analysis, which, you know, if this was our job, we might actually include it. But the best way to deal with it is going to be create 1s and 0s. If someone shares the same publisher, they would have a 1. If someone doesn't share the same publisher, they would have a 0. So, like, you could do all the Square Enix or 1s, and then you could have not Square Enix as 0. Now, with this in mind, you have to think about this. If you have a Square Enix column, if you have a EA column, if you have all these different columns, you start to create too many dimensions. And this could create a problem which is called the curse of dimensionality, where everyone is kind of unique. Like, every video game is kind of unique in its own sense. So what I would suggest doing if you want to handle the categorical variables is you should write an if-else and do the following. You could say if-else and then choose one of the top, like choose the top 3 publishers and give them a 1 if they are the top 3 publisher and a 0 if they're not. Like, let's say EA is the top publisher, which I think it is. So you'd have someone was EA, someone wasn't EA, and then you could put here a column of EA games. And that would be a quantitative binary yes EA, no EA with a 1 and a 0. And then you make another column of, let's say it's Square Enix, and then you say 1, it is Square Enix, 0, it's not, with an if-else. Like, if video game $ publisher equals Square Enix, comma 1, comma 0, store that as a So then do that with like the top 3, but then make a column where it's other. And you could probably do this with genre, like the top 3 genres, and this will give you some sort of idea. Now, you could maybe increase it because it's not going to play as big of a role in the distances because z-scores can be further away. But remember, normalize your data, because if you don't normalize and transform and scale your data and normalize it, then those 1s and 0s are not going to do any sort of creation of distances from individuals. So yeah, that'd be pretty advanced. Like, that's a really great way of doing it. But so don't worry too much if someone's hearing this today and being like, what, I got to use all those variables? It's about understanding the output, and then each business problem has different nuances to it. There's a lot of ways we could go with this, a lot of ways. Every data scientist is going to handle it a little bit differently. Let's go talk about, it was Michelle's question right here. Let's hop into it. Here we go. Population parameters, and then Rajiv, we'll do yours next. Thank you, Rajiv. So population parameters, sampling, and all that good stuff for Stat 201. Stat 201, population parameters, and sampling. Okay, so when we talk about population parameters, what is a population? So does anyone know what a population is? Help me out here. What is a population? Sometimes called a population of interest. Sometimes it's called a population of interest. Sometimes it's called the population of interest. So this would be the group of individuals or things we want to understand exactly. So that's what we call it, a population of interest. Now, parameter's a weird word. Parameter just means, so sometimes they say population parameter of interest. But the only word that matters here is parameter. And this would be the thing we want to understand about a population. So this could be like, let's say like the average age, the average weight, like what do we want to understand? What is the fastest person in the population? There's so many different things we could understand, but that's what we want to measure. We want to understand it. Now I say measure because we will what the population. So we have population being the group, the parameter being like the characteristic we want to understand, but we then go and do what? We take a what of the population. We go and take a what of the population, a sample. So a sample is going to be our insight into the population, taking a smaller group of it. So the population is everyone, everything. But the sample is just our taking a portion of it and saying, let's look at this. And samples give us what's. Samples give us what's. Samples give us what's. A sample gives you a what. If we take a sample, from the sample, we will gain a what. If we take a sample from the sample, we will have a what. SSPP. Samples give us statistics. And that's why we do statistics. So if you just think about the discipline of statistics, great job right there, Shreya, great work. You think about the discipline of statistics, the idea of statistics is that you can't take the whole what to know the truth. You can't, like the reason we make statistics is because we can't get usually data on the full what, which would be a census. We make statistics because we try to estimate what the truth is. So we make a sample statistic. We can't get the whole population. So we say, let's go out and take 100 individuals, learn from them, and then estimate what the truth is. Great job right there, Rod and Shreya. So this is the idea of statistics. I think parameter is just a weird word for most people. Parameters like the grown-up statistics, not the whole cake, just a piece. Shreya knows right there, 100 points. So when you hear parameter, which sounds like a weird word, it's just maybe we would know the parameter at times. Do you think UT knows the average GPA of all students? Could UT figure that out? Does UT have any sort of database access to know, let's say, the true GPA, the true mean GPA? Could UT figure that out? Nice. Could UT figure out the true mean GPA? That's an example right there. Yeah, they could. They have all the data. They got a database. They just go and say, here's the for all students. Now, could we figure that out? So this would be like all UT students. No, we don't have access to all UT students. UT does, but when we go, we talk to 100 UT students, and we would figure out the mean of the 100 students. So if you look at this right here, the mean of the 100 students is a statistic because the statistic estimates the what. Finish this sentence. The statistic estimates the what. So think we have a mean for 100 students, which would be known as, this would be known as y bar, and the statistic estimates the what? We could say a statistic is an estimate of a what? True parameter. Rod knows that is a perfect answer, Rod. That's worth another 50 points on top of that. True parameter, yep. So the statistic y bar estimates mu. And the parameter is the truth for it. And that's correct there also, Jessica. So samples estimate the truth for a population. Samples create statistics, which statistics are the estimate, and we make them from a sample to estimate for everybody, which is the population, the true thing we want to understand, which we usually don't know the truth. The truth is some nebulous thing, like what is the true GPA? Well, maybe UT knows that. So there's one last term right here that we should know also called sample frame. Now, the way I think about a sample frame is I think about a picture. When you think about a picture, or maybe this is like cookies. We're going to put some cookies over here. This person's already walked off with this cookie. It's on their plate over here. This person's already walked off. I say, okay, you can come over and get some cookies. I'm calling this not a tray, but a frame. Which cookies do you have access to sample? Now there are some extra cookies, which maybe is a bummer. People have went and taken these, and they're on their plates. They're not going to be happy if you go take those from them. So when we talk about a sample frame, the sample frame is the idea of we can only take our sample from within this frame. Does that make sense? Outer side, so inside the tray, right? Inside that frame right there is where you can take your sample. So how does that apply in the real world? Well, if you go to Hodges Library and you speak to students in Hodges Library and you talk to 100 of them, you go to Hodges Library, you talk to 100 students in Hodges Library, be very specific. What was your sample frame? You want to understand UT students. Let's write this down right here. You want to understand UT students, and you talk to 100 students in Hodges Library on a Tuesday. Be very specific. What is the sample frame? So this is, usually people get stuck on sample frame. Then we have time for one more question. Because I got to touch one of my bosses. Big presentation day. Woo! So what is the sample frame right here? What would the sample frame be? Thoughts on the sample frame? What would the sample frame be? Great job, Michelle. That's exactly, those are the people you could theoretically speak to. A lot of people say the 100 students, but the 100 students is the sample. So the 100 students is who you spoke to. UT students is what you want to understand, but the students in Hodges Library on the Tuesday are the students you had access to talk to. It doesn't mean you talk to all of them. It's not like you're going to eat all those cookies right there. It just means you could take one of those cookies. So theoretically, you could speak to any student in Hodges Library on that Tuesday. The 100 is how many you spoke to, your sample, and then the UT students is everyone you want to like understand in total. So you don't have access to all UT students. You have access to students who are in the library on that Tuesday. Does that make more sense, Michelle? Like what a sample frame is? The sample frame is where you take your sample from. It's not your sample. It's the things you have access to sample. So let's write that right here. Things you have access to sample. So just kind of understanding this theoretically is very important. When we talk about a sample frame, it's what you could theoretically take. It doesn't mean you do sample them. You could sample everything in your sample frame. You could eat all those cookies. But yeah, awesome, Michelle. Thank you so much. And great questions right there. Little like mini lecture right here. Then we're going to do, I think it was Rajiv's question. But great questions. Let's go do this last question. Thank you so much, everyone. Here we go. Woo! So much fun. We got some big questions done today. Okay. Stat 201. I think it was the... When did Rajiv ask about? It's the newspaper one, right? Here it is. Oh, it's the new restaurant. New restaurant. Smoke-free restaurant. Woo! Chapter 13. Free restaurant. Okay. Let's go grab the Chapter 13 smoke-free restaurant. It's going to be our last question of the day because I'm going to have to... Gotta get some things prepared. Make my next coffee. Get some things ready. Send out the Kahoot announcement. It's a busy day here at Stat 201. But we got it going. Good to see you, Matt, right here. How's everyone's day going? It's the middle of the week. And I can't believe we have less than 2 weeks of school left. Holy mackerel. Like, I'm just like, whew. I'm planning a flight to Knoxville. Gonna fly into Knoxville. We're gonna have a Mario Kart tournament. Was getting that planned out this morning. It's been a busy morning, I'll tell you that. But it's exciting. The exciting idea of Mario Kart tournament. It's gonna be so cool. We're gonna put it on the big screens in the student engagement if we can. A little worn out, I know the feeling, Noah. Have you decided on days for the UTK visit? It looks like I'm going to be there from probably Wednesday the week before till Friday the week it starts. Something like the 17th through the 25th or something like that. So the Mario Kart tournament is probably going to be the first day of classes. So we'll be there in the... I was emailing about it this morning. The student engagement. Did they change this? I don't like it. Well, I really don't like it. Close this off. Close that off. Okay. They changed my Pearson. Literally in the last day or two. Okay, let's check this out. Here we go. Time to look at a restaurant with a smoking area. That doesn't exist anymore. Here we go. Okay, a new restaurant is being planned with 147 seats, and they're looking at possibly... Awesome, Shreya. See then? They're looking at studies that show that 59% of customers want a smoke-free area. They don't want smoking there. So when we look at this right here, we have to understand the notation for this problem. So it wants to know mu plus 3 standard deviations. So what do you think we should find? If it wants to know mu plus 3 standard deviations, what do you think will be the key to solving this problem? If it wants to know mu plus 3 standard deviations, what will be the key for solving this problem? Finding what? And finding what? If it wants to know mu plus 3 standard deviations, what will be the key to solving this problem? So it says we need to know this right here. So we should probably find what and what. What do you think we should find? I'll start writing some hints on the screen. Can't write. What do you think we should find? Cool. Oh, Rod doing some process control right there. X bar and S right there. Process control. 340. Process control. Close. Very close. So we actually we kind of, that's pretty much the answer. Pretty much. We want to find the mean and the standard deviation, not known as X bar in this instance. This instance, we will actually be finding the mean of the distribution is going to be P. And the standard deviation, which is S, is going to be P times Q over N square root. P times Q over N square root. And so this right here is the sigma portion. And this right here is the mean portion, which is mu. So those are the values we're trying to find right there. And, well, what is P? P is the true proportion, and we have an assumed true proportion right here. Can anyone tell me in the chat what P is equal to? What is P equal to for this question? Now be careful, P is usually expressed as a decimal because it's a proportion. It's not usually expressed as a percentage. When we do math, Matt, great job, Matt, right there, 100 points, you got it. And so Matt, do you know, and Rajiv, great work there too, do you know what Q is? Do you know what Q is? If P is 0.59, what is Q? What would Q be? Great job, Matt. How'd you find that? Every semester I teach this, people say, how'd you find that? Great job, Rod, right there. And everyone's showing it, Rajiv, great work. It's just 1 minus Q, 1 minus P, or 1 minus Q is P, and 1 minus P is Q. Good work. They're complements of each other. So now we go in, and we need to find P times Q over N square root. P times Q over N square root. P times Q over N square root. And what do you think I'm going to do with this right now? What do you think is the next step that I'm going to incorporate in this? Because I've now found P times Q over N square root. What do you think I'm going to incorporate into this? So I could write it down right here. That's a rounded version. That's the rounded. I'm going to carry my decimals a moment. So now I'm going to take the standard deviation, which we just found right here. That's the standard deviation portion. I'm going to multiply it by 3. And then I'm going to add it to the what? So I multiplied my standard deviation by 3. Look up the equations there. I multiplied it by 3. And now I'm going to add it to the what? So I multiplied my standard deviation by 3. And that's the rounded. We took all the decimals, and this is the not rounded. And now I'm going to add the standard deviation to the what? I'm going to add it. Great job right there. We're going to add to the mean. And this is not the answer yet. This is the proportion I need. Does that make sense right here? This is the proportion. So if we have 147 seeds, now be careful. This is where people will often hit an issue. Okay. Now, let's pretend for a moment this is the answer. But what if the answer was 104.2? I want you to look at the problem. We're just pretending I did a little different math, and here's the answer. So we're pretending I got 104.2. Now, the question says to round up, to round up, to round up. So I changed the answer for this reason, to make it look like this. It was 104.6, but let's pretend it's this. What should I put in here? What answer? So who knows what answer I should put in that blank right there? What should I put in that blank? So I did all the work. I found the standard deviation. I added 3 standard deviations to the mean. I multiplied that by the sample size. So what should I put into there? What is the answer? Be careful. It says to round up. That's correct right there, Matt. Good to see you here, Caitlin. Yep, Rajiv, you got it. It's 105. That's a common mistake. Please email me if it says you're wrong. I think they make it so 104 is wrong. See, there you go. But make sure to round up no matter what. Even if you get like 104.1, round up. But if you get it wrong and you're watching this, just email me. I mean, it makes sense because you're kind of like saying we need to make sure we have at least this many seats. So if we get like 104.2, we're going to do just round it up. You're welcome, Rajiv. Thank you so much. Great time to ask. We're going to head off right here because we're ending 5 minutes early. Usually go late. But I'm going to call some people and get things going. Awesome work, everybody. I will see everyone in class or tomorrow. You're welcome, Jessica. We're going to send out the announcement about the Kahoot. I'll see you later at Kahoot. Bye, everyone. Bye.